Hi, everyone. Thank you for joining us today for bringing connectivity to the next level. Really excited about this panel and those here to join us today to talk about the exciting world of connectivity and what it means for all of us in our respective industries. I would like for our panel to introduce themselves and give us a little background on who you are, who you're with, and some of the exciting things that you're working on. Hadass, you would like to start us out.
Hi, my name is Hadass Cohen. I'm working at Harman based in Israel. I'm in the automotive industry for almost 8 years, starting with Red Band and then Harman, working mainly on providing experiences to OEMs with software updates and securing the vehicle.
Thank you, Dominique.
Hi, my name is Dominique Freckman. I'm part of global engineering in the automotive business unit of TE Connectivity. I'm based in Zurich, Switzerland, and currently I lead our global road mapping processes for product management, product engineering, and manufacturing engineering. So really looking forward, making sure that we reflect the mega trends in our upcoming products. And prior to that, I led and established our Silicon Valley Tech Office, helping identify new trends and anticipating needs of innovative players and new entrants in the transportation and mobility space. Thank you.
Thank you. Gideon.
Hello, my name is Gideon Kedem. I'm the head of the automotive BU at Valence Semiconductor. We are focusing on providing high-speed resilience connectivity to the automotive industry. And we are the first one to provide and implement the MIPI A-PHY standard that I will elaborate a little bit on later in the panel.
Thank you. And I'm Brandon Branham. I serve as Assistant City Manager and Chief Technology Officer for the city of Peachtree Corners in Georgia in the U.S. What's unique is we operate a publicly funded living laboratory here in the city. We took a public street and partnered with T-Mobile to launch 5G and then opened up this environment for the public and private sector to come together to develop, demonstrate, test, deploy items in 5G, IoT, smart cities, and mobility. Had projects such as autonomous shuttles operating on a public street, interacting with the human population, and also teleoperated e-scooters. Think Uber, but for an e-scooter, you call it, it comes to you. So really, I think a great culmination of this panel to talk about where connectivity is going, where we are now, exciting things that it's going to bring. Of course, when we talk about connectivity, the first thing we have to talk about is 5G. It's all we've heard for the last year since the announcements. So I'd like to get some input from our panelists on where we see 5G, what's it doing in our industry. Hadass, let's start with you. What you're working on at Harman in the vehicle, and where do you see 5G playing a role in that?
Well, the next decade holds significant promise for mobility transformation, from creating dynamic experiences, connecting automobile to the world around them, and making cities and streets safer. The technology and mobility is set to create significant opportunity. The biggest expectation is in the V2X, in the integration of 5G to meet different connectivity requirements for the different use cases. Up to now, V2X communication has been enabled through the use of DSRC, direct short-range communication, a technology similar to the same Wi-Fi technology that we use every day. As we enter into the 5G area, a new protocol is coming to the front, which is the cellular V2X, C-V2X, which is defined as part of the 5G network standard. With the power of 5G, automakers have the opportunity to expand cellular vehicle to everything, the V2X technology that gives our car, buses, infrastructure the ability to talk one to another and the cities around us. V2X will help prevent among vehicle, pedestrian, and cyclists by sending mobile alerts on 5G network, warning of potential incidents. It also delivers vital information from city infrastructure to help users find local deals of parking spots, avoid congestion, and make a reservation, among other things. So eventually, the increase in 5G adoption, the automotive industry must also consider the infrastructure around it to enable vehicle-to-vehicle communication, driving capabilities to operate with lower latency and greater connectivity.
It's interesting. So I know Harman has seen this as kind of the next arena for them with the recent announcement and purchase of Safari. Can you speak to a little bit about that and that integration of bringing those two together?
So at Harman, we are helping automakers to consider how to enable connected automotive experience through the help of RSUs and related technologies like the V2X I mentioned before, so car can become increasingly connected to the world around them. We focus on providing capabilities that support growing set of safety and efficiencies use cases, including the world's first 5G-ready TCU to meet all those needs and create safe and connected car of the future.
No, it's great. It's obviously very near and dear to what I do every day working in the city, kind of leading the way in our transportation lab. We've seen the transmission from DSRC now to cellular V2X and some of the opening of new items that we're able to do between infrastructure and vehicle communication. We're in the process of deploying some cellular V2X roadside units now to begin that testing for the vehicle application, getting our intersection messaging out, our pedestrian crosswalk messaging. So kudos on that work to continue to bring that forward. Gideon, with the vehicle being one of the most connected devices in the world, what do you see happening in 5G to enable this high-speed connectivity?
Well, 5G is a fact. It's happening, and all the OEMs and tier ones we talk to are all deploying this. We are looking into in-vehicle connectivity, so we need to make sure that the infrastructure of the in-vehicle connectivity supports what 5G requires. 5G is all about extra bandwidth and low latency, and it requires resilient EMC-immune, high-speed, high-bandwidth connectivity from the TCU into the car, and this is the thing that we are focusing on delivering to our customers.
Great. Dominique, I know T and Balance has some interaction between this connectivity into the vehicle. Can you tell us a little bit about that and how this all plays together?
Actually, to be very specific, with Valence right now, we provide the actual hardware connectivity, the connector that exactly uses the standards or the specification that Gideon mentioned before. So we are agnostic to what the needs are, but we are able to provide the physical layer connectivity. And in addition to the in-vehicle connectivity that Gideon just mentioned, we also enable the wireless connectivity. So we make sure that the car actually is connected to the infrastructure, for example, to these roadside units. And what we see coming with 5G now, you have additional frequencies, right? There's a new band that has been opened, so you need to make antennas for these new frequency bands. And the challenge that we see, you have now higher frequencies. So, you have lower frequencies. Some of the challenges are in the lower frequencies that have longer wavelengths, and longer wavelengths leads to larger antennas. So one of the challenges that we have is making sure that we kind of squeeze the new antennas into existing packages, right? You don't have all this room to expand. So we have packaging challenges in the future. And then also to efficiently use 5G with its speed and bandwidth, OEMs want they want more antenna. So up to 4 antenna, for example, for MIMO, which is this multiple in, multiple out. So you have now 4 antennas, and again, you have to package them, but at the same time, they need to also be separated so they don't interfere. So we have, for example, 2 antennas on the rooftop in the shark fin, you know, that little piece that sticks out of your rooftop. But then you also start integrating antenna into, for example, mirrors or bumpers. So that gives them a good coverage and also the spatial difference so they don't interfere with each other. So for us, it's this miniaturization and packaging are the challenges for 5G connectivity. And then in addition, looking further out, there will be more frequencies eventually that are being discussed. For example, 30 gigahertz. We haven't heard any specific requests, but we keep watching the market and we have it on our long-term roadmap so that we continue to offer this wireless connectivity.
That's a very interesting point. We actually ran into this in our own testing facility with T-Mobile. They use the massive MIMO technology, 2.5 bands. And then we had some 4G LTE repeaters on some of our roofs. And we were noticing a conflict just between the two when you had a device that was trying to figure out which one to bounce off of. So really interesting to see that play itself out in a real world environment. So definitely something to keep note of as we start to progress through this. And then obviously we're already hearing talks about 6G and where that's going to go. And then incorporating the 5.9 band, especially here in the US, the FCC is starting to release some of that band, some to Wi-Fi and then some to cellular V2X. So we'll see that shift. So all important parts on how all of this works together. So thank you. Hadas, want to throw this back over to you. I personally got to take a tour at the CES showcase 2 years ago when we were all in person and got to see, really that integration of infotainment and connectivity inside the vehicle. They did a great job. Can you talk to us about that side where we're starting to incorporate more of the infotainment into the vehicles as our drivers have a little more assistance and our passengers have a little more free time?
Well, connectivity will impact the experiences we'll have in our infotainment. As the consumers continue to have high expectations for connectivity, they will demand digital experiences that connect across all aspects of their lives. The mobility industry must meet this customer expectation and focus on delivering technology to evaluate their experiences per mile. In 10 years or so, our most important digital device wouldn't be in our pockets like today. It will be in our driveways. We won't focus only on the engine inside our vehicles, but more on the digital experience they provide us. Within the next decade, our vehicle will connect you to everyone else in your life, both digitally and physically. Integrating your digital information into the physical world will be a normal action for your vehicle, your social profiles, work calendars, membership, and health information at all your fingerprints. It will connect you to the places and people that matter that most whenever you just want it. At Harman, and if you talked about CES, we call it a shift from RPM to EPM, and we introduced this in the last CES, which was a virtual one. Moving away from measuring the impact of mobility as revolution per minute to experiences per mile. This pivot helped accelerate the arrival of car as a third place, transforming the vehicle into another connected space to live live while moving through it. And 5G, if we talk about it before, will become absolutely critical to realize this future. With enhanced connectivity and our eventual autonomous future, we unlock the ability to focus on experiences within the vehicle, and 5G and connectivity is essential for this future.
It's really interesting to hear that, because could not agree more. And it's been a fun project. We have a company here testing in our laboratory, and they're doing virtual reality inside the vehicle over the 5G connection. And they weren't able to do that before because they didn't have the connectivity to have the bandwidth in order to run a virtual reality headset inside the vehicle. So no longer, right, do your kids have to hang out in the back seat and watch the boring DVD. Now they can do interactive video games as they ride down the street and not bug us. So it's going to be really interesting and fun to watch what you guys at Harman come up with over these next few years now that we're starting to unleash some of this 5G. Gideon, this over to you. So with all these advancements in the vehicle, do you see any limitations that the car can handle under our current architecture?
Well, you know, talking about limitations, we have a theme in Valence. Our theme is pushing the boundaries of connectivity everywhere. We definitely push the boundaries. We've successfully demonstrated with Daimler in the S-Class, which is now in production. Our high-speed connectivity has been utilized to do all the high bandwidth transmission of video and data that is needed to be done. You know, from the TCU to the head unit to the rear seat unit to the multimedia box. There's no doubt that infotainment today in cars is pushing the limit of connectivity, but we see the real challenge, the limits, not just with infotainment, but more with the advanced driving assistance systems. The new ADAS, which is being designed and deployed today, those systems are utilizing an ever-growing number of sensors. We see use cases with different OEM where they are combining 20 to 30 sensors into a single vehicle. You know, those can be cameras, long-range radar, short-range radars, lidars, surround view, etc. And the requirements for bandwidth is growing constantly from 4 gig to 8 gig, even 12 gig. So this is really pushing the limits. We see that the existing proprietary solutions are running out of steam. They're unable to scale up. And we think that what is needed for the industry is a standardization. There's a need for standardization to break through the limitation. Standardization, first of all, to have the OEMs not dependent on proprietary solution, but also to deliver a high-speed resilience connectivity and what we see as end-to-end holistic solution. Recently, the MIPI Alliance, which is the owner of CSI and DSI, the protocol which are used to transfer video in the car and into the display, the MIPI Alliance have defined the AFI standard. And the AFI standard is actually addressing the requirements that I've mentioned. And we're very proud that MIPI have chosen Valence technology as the base for the AFI standard. And we're excited to be able to deliver this to the market very soon. We've recently taped out the first family of devices, both transmitter and receiver, and we will have engineering samples to our customers in October. So to summarize the limitation as we see it, we see the ADAS system, the asymmetric link in the car between the sensor and the ECU as the one who are requiring more bandwidth, as the one who are putting the limitation. And we see the standardization of AFI as the solution for this limitation. It is a scalable resilience solution that we will continue to deliver to our customer.
Thank you. Now, I know hearing all of this data transmissioning from roadside units, in-vehicle communication, 5G connectivity, all of this data transfer that's happening, my CTO brain just starts going off about security and how do we protect the vehicles. And then just last week we had the announcement that one of the Tesla vehicles mainframe computers was hacked over the air through one of the over-the-air updates. So Dominique, how do we start thinking about, secure data transmissions as we integrate all of these parts from all of these different manufacturers and partners?
Actually, right now, our primary focus is the reliability of the connection itself, so that you actually don't lose any electron or any bit of data. That is our first focus, that you have a really absolutely solid communication, because especially if you have more and more sensors, you don't want to drop anything. So what we do right now, we focus more on automation, for example, in our manufacturing, to make sure that the overall reliability, the consistency of this connection is absolutely solid. The other part, and this is where we still see a challenge or a need in the industry, and actually that is one thing we put at EcoMotion into the Market Innovation Challenge, I think that's what it's called. How can you ensure the integrity and the authenticity of a sensor? So for example, you have your whole system, everything is well set up, but let's say you have a problem, you need to exchange one sensor and you put a different one in. How do you know that this one is the same proper sensor, right? If you think about an aftermarket, or let's say if you don't have exactly the same brand, this type of, when you have a data structure, you put in, let's say, a printer into your home network, and the printer says, hey, it's me, you can trust me, everything is good. We don't quite see this on the sensor side yet. So that's actually a challenge that we put out. And if somebody has a good idea, please talk to us, and then we can work out with our physical connection, make a solid solution out of it.
That's great. I think that goes right into what Gideon's saying. Some standardization across these parts are going to really drive how we can securely and safely and maintain all of these connected devices in our vehicles. I know all the news everywhere across the country is all about the electrification of fleets. So I want to hit on that as we're closing out just a little, because I think this is going to be the future of how we have to think about the integration of all of these devices into the vehicle, going away from the combustion engine to a full form battery factor. So Dominique, as we talk about electric vehicles, the first thing in the consumer's mind is, well, I can't take my 300-mile trip across the country. I've got that range anxiety is still a really true thing for a lot of consumers who are hesitant to switch to electric vehicles. What's some of the work you're doing at TE to address this?
So yeah, range anxiety, I think that's the buzzword when it comes to, how can I charge? How quickly can I charge? How much more power can I push into the car? So where we come in, again, we provide that physical layer connectivity, for example, a charging inlet, and then also the hardware connectivity from the inlet to the battery, from the battery to all the other components that you have. And the moment you get all this power in, you have an enormous stress on your material. So it's literally that piece of metal where, the power comes in, the power needs to be transferred, and it needs to be pushed into the car. And the more resistance you have, the heat that evolves, you need to either make sure you reduce the amount of heat that happens during fast charging. So we work on improving the metallic materials. We also work on improving the plastics around it to make sure that they can handle all the stress of the power. And then even also within the car, make sure you, as best as you can, first you reduce your heat sources, and then also that you can disseminate or just cool down your whole system. So we also have for customers simulation tools actually available on our website, where you can try out and see with the thermal management what is the best that you can do to handle and manage all this power that comes in, especially during fast or extreme fast charging.
That's great. Thank you. Hadass, I'll come over to you. With all the integration and new technology going into the vehicles from the Harman side, how do you see that interacting with electrification of vehicles? And then do you see the electric vehicle infrastructure like the fast chargers or level 2 chargers serving as a connectivity point for these new technologies?
So the move to electrification has drastically lowered the barriers of entry around building cars. It's catalyzing new breed of entrant with consumer electronics and mobile focus. Consumer electronics companies are now exploring the idea to design their own electric vehicle as expansion of their product portfolio. Actually, those new EV entrants are shifting consumer expectation and technology needs, and they are disrupting the value proposition of car. Experience bias through consumer electronics, changing perception that the car is an electric device and not a machine. Therefore, all the trends we talked about before that impact the connectivity on the consumer is amplifying and accelerated with the entrance of electric vehicles. This leads, first of all, to more software in the car, more sensors in the car, and increase the car cyber attack surface. To handle this, it's challenge to the OEM, and they need harmonized security ecosystem that hardens all platform to safeguard against cyber attacks and empowers consumers by controlling how their data is shared with third parties and protected, as the car involve much more personal data and personal information of the drivers. In addition, a secure and reliable software update platform is required, allowing the OEM to update their fleets, all the sensors, all those software in the vehicle as fast as possible, securely and safely. And it includes the vehicle itself, the sensors, and now it expands also to the charging stations.
Thank you. Gideon, as we, as one of our only Israeli companies on this call, how do you see the OEM, world interacting together with, our Israeli counterparts and some of our startups that are here in EcoMotion? How do you see that happening in the future?
Well, I think that collaboration is key, although you can see different direction and different thoughts with different OEMs. I think that collaboration is key and standardization is key, and I think the industry will get there, right? I think the industry will get there. I think that without this, it will be very difficult to achieve, right, the level of security and the level of connectivity which is required. If you look towards autonomous driving, which is still far ahead of us, right, this is essential, right? I think that without this collaboration around the standard, it will be very difficult to achieve what is required.
Yeah, agreed. It is a great place to come together. So in our wrap-up time here, I'm going to ask one last question on just really where you see the future of our connectivity going and what's going to be important to help really pave the way for that. Hadas, we'll start with you.
So we see that the connectivity 5G is allow new technology to be integrated into the vehicle. It allow OEMs to provide new experiences to the driver, and it's helped them turning the vehicle into a new experiences, just like you mentioned before, like a playroom to your kids or a creator studio or remote office. So with 5G connectivity, advanced technologies enable everything to the driver to get new experiences from the vehicle.
Couldn't agree more. Dominique?
Well, for us, the challenge, what we tackle for next generation connectivity is packaging and miniaturization for harsher and changing and increasing demanding requirements. And there we use our expertise in materials and design and simulation to address these next gen requirements, both for high-speed data as well as high voltage.
Great, thank you. Gideon?
Well, I think, as I previously said, I think The industry needs standardization. The industry, if I look into in-vehicle connectivity, the industry needs a scalable, resilient, error-free, EMC-immune connectivity. I think that the A-PHY standard is delivering all this, and we see a lot of momentum of an ecosystem building around this standard. Just to give a few examples, companies like Mobileye have recently announced that they will integrate the A-PHY connectivity into their IQ5 ECU and also to future generation. Sony recently announced that they will integrate it into their sensors. So we see a lot of momentum. I think the industry is coming together around the MIPI A-PHY standard. And I think this is the right way to break through the limitation which we are facing today.
Yeah, agreed. From us, we see that there's got to be great collaboration between private and public industry in order for this to happen, because it's going to take public infrastructure to really bring connectivity to all throughout all of our areas, all of our cities. So we've got to come together and do this. It's what we're trying to accomplish here at Curiosity Lab, bringing us all together in a single place where we can really push this forward. So I want to say thank you to our panelists. Great conversation. I'm really looking forward to continuing this and hope everyone enjoys the rest of their show.
Thank you. Thank you very much.
Thank you.